So welcome and thank you everyone for joining us. We're going to present the result of a work and a paper that we published some time ago on the role of energy sufficiency, specifically in the EU, and its importance in the long-term perspective, long-term energy scenarios. So I will say a few words about EnerData. If you can just switch slides here very quickly before we get into it. So for those of you who don't know us, we are an independent and energy research and consulting company. We've been operating for more than 30 years. Basically specialize in the field of energy as a whole, but also emissions related to energy and climate issues overall. We are producing a lot of different databases related to energy and have a lot of tools that I can say a few words about in the next slide. We are located in Grenoble, a small city in the French Alps, but we also have offices in Paris and Singapore, and mostly we have a global outreach in terms of clients. And also in terms of the types of clients, we work with public institutions, directly with countries, financial, corporate actors, NGOs, etc., utilities. So yeah, a large portfolio of different actors across the world. A few words on basically we are combining a lot of different tools and competencies that we apply specifically to the energy field. We have a lot of modeling tools, specifically the POLES model that for which we're going to talk about it a little bit, because this is in part the results of the POLES model that we are presenting today. Expertise in the field of energy and climate, market intelligence as a whole, either like general subjects related to energy and climate, or more niche, specific to technologies, etc., and a lot of data science also, and all of that to produce a lot of different services and products, but also to work directly with clients to produce different projects and different types of deliverables, helping clients all over to better understand basically the field of energy as a whole. So I will leave the floor to Aurélien, who will start talking about the subject of today, which is energy sufficiency in the EU.
Thank you, Quentin, for the introduction. Very helpful. I take this chance to remind everyone that you should use the Q&A chat box to ask any questions that you might have during the presentation or after the presentation. There will be a time for Q&As at the end, so don't hesitate to write to us in the chat box, and Quentin will either answer some of the question with a written answer or select some questions that we will treat at the end of the webinar. Now, without further ado, let's dive into sufficiency. So the starting point for the analysis that we produced is the fact that sufficiency, and especially energy sufficiency in our case, is a concept that is recently gaining some traction. And this, I mean, a few examples of this are the three that we put here on this slide. The first one is the fact that the IPCC, in its latest reports on climate change, included a part of the analysis about energy sufficiency and sufficiency. So it's actually a great recognition for the concepts, and it's actually a massive step towards the broader use of this concept across perspective and policy making in the future. So that's one of the first steps. That was in 2022. Then in the same year, through its REPower EU plan, the European Commission made some sort of introduction, not to the sufficiency term itself, but rather including some forms of behavioral measures to reduce energy demands as part of the measures in this plan. And that's already also a step in the same direction mentioning the fact that with behaviors we can reduce our use of energy, and it's not necessarily through technological solution or efficiency. And finally, maybe what really started gave us this idea of this analysis was the publication in the Nature Communications Journal of a paper that was illustrating the work from the clever scenario that we will mention once again in a few slides, but that was produced notably through network of stakeholders across Europe, led notably by the Negawatt NGO that launched this effort. And it's a scenario where sufficiency plays a massive role in lowering the energy demand in Europe to ensure a feasible pathway towards carbon neutrality, basically. So that was kind of a long intro, but let's look at the agenda of the webinar. So we've done the introduction. Now we are going to look at different scenarios that exist out there and try to understand how sufficiency is mostly absent from a lot of scenarios and what consequences it has. But before looking into that, we'll also discuss a little bit more about what we mean by energy sufficiency and some sort of definition. Then we'll look at some results from our own scenarios named EnerFuture scenarios to look at the role that sufficiency can play to reduce the demand in an ambitious framework and looking at sectoral results to illustrate that. And then we'll just conclude based on that agenda. A few words about the speakers that you see in front of you. I'm Aurélien Peffen. I'm heading a small team on prospective and scenario here at EnerData. I've been there for almost 8 years now, and focusing on long-term prospective analysis. And I'm joined by Elena Adjur, and please introduce yourself.
Yes, hello everyone, and I'm Elena, and I work on sufficiency subjects with a sometimes more social perspective, and as we hear in this webinar, with the modeling perspective. And I also work on other subjects linked to climate adaptation and international negotiations abroad, amongst others. So let's dive into this presentation by starting with a few definitions of what is sufficiency. So as we said, the IPCC in its 6th assessment reports recognized and introduced a definition of sufficiency as the broad concept of sufficiency, not only energy sufficiency. And so the IPCC defines sufficiency policies as a set of policy measures and daily practices that avoid demands for energy, but also for materials, land, water, and all natural resources, while delivering human well-being for all within planetary boundaries. So we do make a difference here between the general concept of sufficiency and energy sufficiency, and today's scope will focus on energy sufficiency mostly. So this definition of the IPCC can be more largely engraved in the sufficiency, efficiency, and renewable framework, in other words, the SCR framework, which was firstly proposed by the Negawatt think tank. So here we can then make the difference between sufficiency, which is about prioritizing essential needs at individual and collective energy usage. So for instance, we're going to use an appliance which is smaller, or we're going to use a car which is smaller, or try to travel less. Whereas when we talk about efficiency, it's about reducing the amount of energy required to satisfy each need. So here it's more about using technological improvement to have a car which consumes less, or about insulating a building, for example. So these two levers, sufficiency and efficiency on the energy consumption side, are complementary together, and they goes with, on the supply side, the development of renewables. Yes, we can go to the next slide. We thought it was interesting to remind you with these visual framework of sustainable development, the donut economic concept, which was developed by Kate Raroth, an economist, because it gives a good visual framework of sustainable development between a lower boundary, which is a social foundation for delivering human needs, basic needs, such as having good food, water, energy, and at the same time, without overpassing planetary boundaries, which is the ecological ceiling. And the interesting aspect of sufficiency is that even if we here focus on energy sufficiency, it also shows that sufficiency can be more broadly thought outside the scope of energy only, with other planetary boundaries on land, on water conservation, etc., as shown in the donut economic concepts. Let's take an illustrative example in the car industry sector, so as to make the difference between energy sufficiency and energy efficiency. Here, this graph shows an evolution of different indicators between the 1990s and 2015. In dark green, we can see that the average consumption of cars decreased since the 1990s. So it means that there were some efficiency gains in cars. But at the same time, if we look at the lighter green and at the lighter green index, we can see that CO2 emission of cars kind of increased. And so the total consumption of cars increased. It can be partly explained by the size of car, which tend to increase in the last years. And also, if we look at the purple line, we can see that there was an increase in the total distance traveled by cars. So even if on one side there has been some efficiency gains, at the same time, there were also an increase in sufficiency indicators. Here, the total distance traveled by car and the consumption of cars. So the efficiency gains were offset by the absence of sufficiency measures. And we can talk here about a rebound effect. We thought it was interesting to show you the different dimensions of energy sufficiency, which can help to operationalize the concepts. So, for instance, when we talk about dimensional sufficiency, we talk about adjusting the right size of energy service to its right purpose. So, for instance, maybe I don't need a huge SUV car to go grocery shopping at the end of my street. I can use a small car. When we talk about cooperative sufficiency, it's about sharing energy services so as to reduce consumption using car sharing, or, for instance, sharing the use of some appliances, such as washing machines. In Switzerland, you have some rooms which are dedicated to collective washing machines where people can use and share the appliance. When we talk about usage sufficiency, it's about reducing the duration or the intensity of an energy activities. So, for instance, I'm going to try to reduce my speed on the highway or lower the temperature of the heater. But it's also about increasing the life duration of equipment. And finally, organizational and structural sufficiency touches to the very collective aspect of sufficiency, because it tries to organize spaces and human activities in cities, for example, so as to minimize the need for energy services. So we will talk about it a bit later in the webinar, but we can take the example of the 15 minutes city model, where every energy services or public spaces are located in a 15 minutes walkable area so that people can reduce their need to travel in the city.
Thanks a lot, Elena, for this introduction. I find these four dimensions of sufficiency very useful to get a more concrete sense of what it actually means to reduce our energy need through collective or behavioral changes. And yeah, to me, it really helps to get more concrete on that. Now, based on this definition, we'll look at a few scenarios that exist out there and to try to understand what the implications of sufficiency might be in such cases. So here you see a graph with a vertical axis showing the demand side effort in a set of scenarios. Those are the dots that you see on your screen. It's just a selection of scenarios that we found out there. And we try to quantify the demand side effort through sufficiency, efficiency, also electrification that help to decrease the final energy consumption. So those are shown on the vertical axis, and then on the horizontal axis, it's rather the supply side levers used in these scenarios through renewables, hydrogen, use of CCS, and in general decarbonization actions, let's say. Now, all of these scenarios are, let's say, rather ambitious scenarios that are close to a below 2 degrees sort of trajectory or towards a net zero. So not all of those have the exact same ambition, but those are rather on the high side of ambition in terms of scenarios, right? So we see here that there are different sort of strategies in the scenarios that are being used. On the top left side of the graph, it's rather the scenarios that use a higher focus on demand side levers. On the bottom right, it's scenarios that have a tendency to use more supply side levers, right? And we can see there are some differences there. But what I really want to show here is on this next slide is now we replace the dots on the same graph with areas, and these areas show the sort of an indicator that we created on the reliance of these scenarios to new technologies. So by new technologies, we mean hydrogen and e-fuels, CCS, negative emission technologies. So those are technologies that we know exist, but are on the low maturity kind of things. And where we typically show on this graph and can note on this graph is that the further we go to the bottom right of the graph, the higher the area is, which means the more you rely on supply side levers, the more you rely on low maturity technologies, basically. And that's, I think, a very, very interesting comment to make. Now, I circle in green the EnerGreen scenario, which is produced by Enerdata, and that we will discuss later today. That includes some sufficiency, but also efficiency, renewables, some use of hydrogen and CCS, but just to a lesser extent compared to some other scenarios that you can see here on the graph. But yeah, the main point that I want to make here is that in existing scenarios to 2050, let's say, that we see out there, the sufficiency concept is not majorly used, and the higher the focus we have on the supply side, the higher we rely on non-mature technologies. And that means that basically these scenarios present a higher sort of uncertainty in terms of first, technical feasibility, right? Will we manage to achieve that level of negative emissions through technologies, even though today only a few pilot projects are operating in terms of CO2 storage? That is a question. I'm not saying it's not doable, but there is an uncertainty about that. The same goes for the economic viability, because Well, of course, the developers for direct air capture projects, for instance, will tell you that the costs are going to go down quite significantly with the build-up, and I mean it makes sense. But how sure are we that we will have let's say a lower cost access to such technologies? There is an uncertainty about that. And also, of course, there is an added pressure on the resources when we look at technological options rather than sufficiency options that don't imply an additional reliance on materials or anything. So I guess this chart is quite insightful to that regard, and I think we will dwell further on our own EnerGreen scenario just to show you, I mean, to what extent the sufficiency can help to reduce demand in our own modeling framework, basically. But first, just listing some scenarios that integrate some, I mean, at least to an extent, some energy sufficiency in there. And I won't go through all of the list, but we can see that at global level, there are a few scenarios out there that incorporate such assumptions. So it's either reducing the energy demand and mostly through efficiency, but some of these scenarios include sufficiency as well. So we can cite the low energy demand scenario for the global north. From the IPCC, there's this NGFS low demand scenario as well. So NGFS is the Network for Greening the Financial System, and they produce a set of scenarios, including one that is focused on low demand. There are others out there that you can see on the slides. We mentioned also the clever scenario at the European level that is produced by this stakeholder network and led by the Negawatt NGO. We just to mention our own scenario, as we said, the EnerGreen one that we'll discuss, and then there are a few national scenarios as well, as you can see on the bottom of the slides. So the purpose of this scenario, I mean, the way that energy sufficiency brings benefits in this scenario, and what we observe is that it helps to decrease the energy imports and therefore decrease the dependency of, for instance, Europe to other countries to import energy. And in this geopolitical context that we have seen in the past years, it's not necessarily a bad idea to focus to some extent on energy independence in a world that keeps changing, and we don't see how the markets will evolve in the future. Of course, it helps also to reduce the environmental and social damages, thanks to a reduced pressure on the use of materials. It also helps to reduce just the GHG emissions, right? So it's also, of course, a benefit. And there are also, to mention, some cross-sectoral benefits through sufficiency. Basically, an example for that is that if we reduce the use of cars and we use smaller cars, then on the industrial production kind of side of things, you need to have less materials, less steel to produce the car, less materials in general and resources. So, applying sufficiency to a sector might have effects on other sectors as well, and that's a co-benefit that comes with it. So it's really about a systemic view of the benefits here. Okay, I think we've discussed a lot about this existing scenario, and now I want to go into the some results from our own EnerFuture scenarios and see to what extent sufficiency can help to lower the demand and therefore contribute to a decrease of emissions. Just before going into the results, to give you an idea of the framework that we are working with here, those are the three scenarios that we produce yearly through our EnerFuture platform. In our EnerFuture platform, we have a business as usual type of scenario named EnerBase. that leads to a temperature increase above 3 degrees, which is basically a continuation of the existing policies and trends. So business as usual type of scenario. Then we have a scenario accounting for the indices and country targets that were submitted up to the end of 2023, but we'll actually update this scenario in a month from now with policies up to 24. And this scenario leads to a temperature increase between 2 and 2.5 degrees, something like that. So that's accounting for all of these pledges. And then we have finally our EnerGreen scenario that is ambitious, in line with the Paris Agreement, and that leads to a temperature increase well below 2 degrees. And all of the scenarios that we produce yearly are based on our Poles in a data model, that is a global model for the energy systems and the associated GHG emissions. I won't go into the details of the methodology here, but if you're interested, feel free to reach out. To give you just a very broad overview of what the scenarios look like, we have contrasted trends in terms of energy consumption with, the EnerBase scenario failing to decrease the growth in energy consumption worldwide. So all of these graphs are at world level, right? Then the EnerBlue scenario manages to stabilize the energy consumption, while the EnerGreen scenario enables to decrease it quite rapidly and then stabilize again. This is combined with a very contrasted picture in terms of share of fossil fuels. So we see fossil fuels decreasing very rapidly in the EnerGreen scenario, reaching something like 20% by 2050, whereas in the EnerBase scenario, it's decreasing quite slowly. And then if we add up these two effects on demand and on fossil fuels, we obtain these CO2 emissions that you see on the right that are very contrasted, basically. And now we will focus on the EnerGreen scenario, which is our most ambitious scenario, in which we took some assumptions on sufficiency. And just to give you, this in one number, in the EnerGreen scenario, we have a 50% reduction in the final energy demand by 2050 compared to 2022. And to explain this 50% decrease, it's 40% related to sort of efficiency gains that are either through pure efficiency or electrification that implies efficiency gains in the final energy demand side, and it's 10% due to sufficiency. So this number is it's not like a massive number, right? It's not the majority of the reduction of the energy demand that is done, but it's still a fifth of the energy demand reduction that is obtained through sufficiency. And 10% is already very significant. And when we look at the impact in the different sectors and the reliance on technology that I showed before, it's really key. Every additional effort in an ambitious scenario is very useful to reach a more sustainable pathway, basically. I think I'll just stop there and give the floor to Elena to present a focus on the residential sector, where a lot of possible sufficiency measures can be implemented.
Indeed, thank you, Aurélien. And just maybe a reminder as a context, in the EU, the building sector is one of the most energy-consuming sectors. So it is a key sector where it makes sense to reduce the final energy consumption, and especially in the residential sector. So how did we modelize sufficiency and behavioral changes in EnerFuture? We used different indicators that we listed here, such as space heating, which is the average energy service per square meter of a dwelling, impacted not by efficiency and isolation, but really by the behaviors of people and how you use the temperature of the heater, for instance. The same goes with the indicator on space cooling, which measures the energy service of the AC of the dwelling, and also the share of dwellings which are equipped with some AC units. Then we also have other indicators such as appliances and lighting, how people use them. The same goes for the cooking, how people use the oven, and how people consume water as water heating women here. So when we combine these 5 sufficiency behavioral indicators, it ends up, as we see here on the graph on the right-hand side, in a reduction of the energy service per capita of 23% in 2050 in EnerGreen, compared to the EnerBase scenario, so the business as usual scenario. So here in the residential sector, sufficiency indicators and changes is key and represents an important reduction of the final energy service in 2050. If we go to the next slide, please, we seen that we did integrate some quantitative indicator for sufficiency, which transcribe mostly some individual behavioral changes. However, these individual behavioral changes must be facilitated by collective enablers, both at political and at institutional level, so that people and citizens, when they change their behavior, they do it without impacting on their comfort needs. And it is key then to have these collective enablers. We listed here some example of these collective enablers. In the residential sector, renovation policies are key to isolate dwellings. So this is an example of an efficiency gain. However, if we have a dwelling, an apartment, which is nicely isolated, it means that as an individual, I can reduce the temperature of the heating, I can use less air conditioning because my flat or my house is nicely isolated. So I don't reduce my individual comforts, and I can reduce the heating temperature. And at the end of the month, I can also make some energy saving cost and reduce my bill. Other measures at collective levels which are complementary to the renovation policies include the regulations and standards, whether they be at the European scale, the national, or the local scale. We listed here some examples of policies. I won't go into the detail of all of these policies, but for instance, at the EU level, there has been a revision in 2024 of the Energy Performance Building Directive. And this directive, one of its main objectives is to increase the rate of the renovation of buildings at the EU scale, going first with the worst performing buildings, and by introducing as well some energy performance standard certificates so as to increase this renovation pace. At the national scale, if we take the example of Sweden here, this country implemented some carbon taxes, some tax credits, and also some information tools to foster renovation so as to accompany people when they renovate their building. And at more local level, some cities such as Barcelona and Brussels implemented water pricing measures. So as an individual, I don't pay the same price for water depending on my consumption of water. The more I consume water, then the higher price I'm going to pay. And finally, education and new social norms are important to accompany these behavioral changes. We have seen in Europe, at least, and in some countries, that there has been a growing civil support for sufficiency, the concept of sufficiency. For instance, in the conference for the future of Europe, in this French conference, each country had a conference, and in France, French citizens voted for sufficiency as #1 priority measure amongst a list of 14 key priority measures for the future of Europe. So it shows some kind of public support, even if people are willing to accept this idea of sufficiency. There are some barriers when it comes to implementation, and people are asking for policies and states to help create the enabling environment to help them make these sufficiency changes. So we will go now in another sector presented by Aurélien, which is the transport sector.
Yeah, so basically to give you another angle at how we obtain for Europe this 10% contribution of sufficiency in the broader 50% decrease in energy consumption. And transport is really the other sector where sufficiency can play a big role. So here you see on the left side of the slides, two indicators that we looked at is first the road transport passenger traffic. So that's basically the traffic through cars in passenger kilometers mostly. And on the bottom side, you can see the occupancy rate. So it's the number of passengers per car. And in EnerGreen, compared to the BAU scenario, there were assumptions made and that relates, that enable to transcribe, for instance, the spatial planning of cities. So it's this example of 15-minute cities that Elena mentioned earlier, or it's also about the remote work, for instance, the fact that people will maybe work from home a day or two in the week, which reduces the trips in cars from home to work. And if we add up all of these types of measures, then it helps to reduce the traffic in passenger kilometers from a growing trend to a slightly decreasing trend, which means that by 2050, in this EnerGreen scenario, we assume we will have around the same traffic as we had in the early 2000s, basically. And then combined with that, we have these occupancy rates. So the number of person that you have per car in average, that is increased, notably through more, carpooling sort of measures. And therefore, we assume that from today's something like 1.5 person in average per car, we will reach something like 1.8 by 2050 in this scenario. And if we add up those two effects, it's actually a traffic in vehicle kilometers that is reduced by 42% in 2050 in EnerGreen through sufficiency compared to the baseline trajectory, right? Which means there will be 42% less trips made by cars in vehicle kilometers by 2050. And that's huge because, of course, the energy consumption is related to the number of kilometers that are traveled by those passenger cars. So that plays a massive role, the transport sector, in what we obtain at the aggregate level. And it's really a sector where we see lots of possibilities for sufficiency to play a role. So we've discussed, carpooling, remote work, etc. But it can be also about switching from individual cars to other modes of transport. Could be public transport, could be biking, etc. And this can definitely be unlocked by collective enablers, as you said, also for the residential sector. So if you have a city planning that accounts for the fact that people will less use individual cars, it really helps to boost these sort of sufficiency measures. So it's not only about individual behaviors and saying, okay, I'm going to go bike to work, but it's also about having a city that enables you to do that, for instance. So of course, it's not about having everyone switching from one mode to the other, but by accounting for individual and precise types of actions, as we did here, we see that the impact can be massive already on the traffic. So now a few takeaways, maybe, if you agree to give us some form of conclusion of the discussions we had today.
Of course. Let's conclude and give you a first key takeaway, which is that it is essential to integrate alongside the efficiency levers some sufficiency measures and indicators, both in energy scenarios and also in policies and at the societal level, so as to reduce energy demand and help us to decarbonize Europe more rapidly, but also by reaching sustainable development goals and avoiding rebound effects. And there has been some recent recognition of the sufficiency concept at the European, but also at the international level, which is a good positive move for increasing sufficiency measures. Then secondly, prioritizing energy demand reduction through sufficiency levers, as you said, Aurélien, also brings co-benefits. It reduces dependencies, it helps to reduce the use of low mature technologies, and then thus it decreases the need for raw material resources, critical raw material, and is going, as a result, decrease geopolitical risk, which are induced by the use of these technologies. Thirdly, when we do integrate sufficiency levers in the transition, it can also limit the energy system cost of this transition, because when we do integrate some sufficiency measures, it's going to bring positive co-benefits, such as a reduction of air pollution, increased quality of food, and thus public expenses are going to be reduced. Technological levers, such as the use of CCS, are also quite expensive. So by combining and integrating more sufficiency levers, we reduce the cost of use of these technological levers. And sufficiency levers, as we said, do require new rules and social-cultural narrative. It is less costly, but it might also take more times and be prone to face more acceptation barriers that we do have to keep in mind when integrating sufficiency in the transition. Other key takeaways include that, as we've seen here in the case of the inner green for the for the EU region, they can contribute to reducing final energy demand to about 1/5 in 2050, compared to an urban scenario, so the business as usual scenario. And in some sectors, combining sufficiency and efficiency measures enable even greater energy consumption reduction, as we've seen in the residential sector and in road transport sector, which respectively account for 23% reduction of the final energy service per capita in 2050 and 42% reduction of the total road passenger traffic in kilometer vehicle in 2050. Sufficiency levers transcribe individual behavioral changes, but they must be facilitated, as we saw, by collective enablers at the societal levels, with a combination of both new norms, new regulations, education, and institutional levers, with the development of new public infrastructure for transport, for instance, and new incentives to boost the development of sufficiency. And finally, beyond energy modeling, we think it is key to also identify other existing sufficiency measures at a European and at the world scale, because their results is also important to develop and boost the credibility of the sufficiency in scenarios and at the collective level. Here we put a picture of a manifesto which has been co-signed by about 30 stakeholders, which do include some think tanks, some public institutions, and some NGOs. This is a manifesto for putting sufficiency at the heart of the features of the EU's policies. It has been published in March 2024, and we can identify other sufficiency measures and research going on. I can think about the Fulfill project, the Enough project, the Odyssey Mur database, and other international and world initiative, such as the International Sufficiency Lab, which has been launched in 2024.
And I think thank you a lot, Elena, for this conclusion. I think it's now time to move to the Q&A session. I hope the presentation was clear, and happy to take the questions.
Yeah, well, first of all, thank you, both of you. I'm a little bit biased, but I thought it was pretty interesting. We actually do have a lot of interesting questions. Allow me to start with some clarifications on the results that you've shown. First one, I think it's around a slide, maybe 18, 19, 20. But I think overall in the presentation, just to clarify, what is the exact scope? Are we talking systematically about the EU, especially for this particular result, or is it global level?
That's true. That's a good point. So we focused on the EU side of things. So here, when we're talking about the 50% reduction, it's at the EU level. It's also because sufficiency in the EU is pretty clear. The use cases, the measures that can be developed. I mean, maybe we can dwell on that further after. But when we are talking about other geographies, such as developing countries, then sufficiency does not have the same meaning and actually is not nearly as applicable as what we see in developed economic context such as the EU. So here is the EU. Just before the slide I showed about the general overview of the scenarios, this was the only global picture. It was just to show the context of the EnerFuture scenarios. Apologies if that's made anything unclear, but yeah, the whole presentation we made on the residential levels and transport levels, everything was at the EU level.
Yeah, thanks for the clarification. And actually, going back to slide 20, sorry, we just skipped all the way to the end. There was a question on basically, I think it's worth, and by the way, indulge me for paraphrasing and extending a little bit sometimes the scope of the question that you had. Basically, there was a question on whether we are talking here about energy efficiency or energy sufficiency, which maybe, Elena, you can say a few words about this, but overall, I think it would be interesting to explain a little bit more how in the model we actually differentiate between these levers specifically.
Yes, so here we are talking about energy sufficiency. And sorry if it wasn't that clear. If we take the example of the indicator of space heating, here what we measure is the number of kilowatt of energy which is used by using a heating which is impacted by the temperature I'm going to put on my heating, and not by the level of isolation and renovation of my flat or my house. So it's really focusing on sufficiency and not efficiency. But on the other side, in the model and in EnerFuture, we have other indicators which focus on efficiency.
Yeah, definitely. And then to complement that from the modeler's perspective, basically, we have introduced in the model, for instance, for the residential, we have three type of main indicators, let's say, that quantify the energy demands. We have the energy service, which is what is shown here, and that really transcript the need for energy by people, and that's where sufficiency can help to reduce that indicator. Then we have some useful energy, what we call useful energy, which is then the transcription of the service per capita, but accounting for some efficiency effects through insulation of buildings, for instance. So the better the insulation of your building will be, then the higher will be the gap between the energy service will be translated into a lower energy useful energy need, let's say. And then there is the final energy, which is the actual energy that is consumed in the building, and the difference between the useful energy and the final energy will be really the technical efficiency of the equipment that you use. So for instance, for the space heating, it will be your boiler, and the higher the efficiency of your boiler will be, then the lower the gap between useful and final energy will be. Yeah, I hope this helps to clarify this question. Maybe we had these slides as a backup that can also help this point, just to give an example of the differences between sufficiency and efficiency. Maybe you can take that over.
Yes. So here, for instance, if we go back to the example of the building sector, an example of sufficiency is to optimize the size of the building of my dwelling to the number of occupants in the dwelling. And yes, in Europe, for instance, in some countries, it does make sense to think about this indicator, about the average individual floor area per person. But in other countries, we won't think about reducing this individual space where it is already quite small. So we also always, with sufficiency, have to put things into perspective, depending on the national context or even the local context. And on the efficiency side, here, yes, an example would be to increase the efficiency of the equipment and increase the retrofitting of the building.
I think we won't go into all of these examples, but
Yes.
you have those on the screen. Those are just examples, right? There are lots of measures that could be discussed.
Yeah, thank you. I'd like to go to other questions that some of them touch on maybe the limitations that we have and the limited scope that we operate within. First, and maybe address that very quickly, but I thought it was interesting. So there was a question about how, because we present EnerGreen in other scenarios when we do this benchmark. First of all, the benchmark is on, if I'm not mistaken, on a global level, because it's from another study, basically. We present EnerGreen as being relatively virtuous in terms of energy demand reduction, but it doesn't really compare to other scenarios that are, for example, the clever scenario in Europe, which is much more ambitious in that regard. How would you, in general, define the level of ambition in terms of efficiency and energy in EnerGreen? We saw the figures about 10%. Are we talking about major behavioral shifts, or is it really marginal improvements in terms of sufficiency?
That's a good question. I'd say EnerGreen. I mean, the EnerGreen scenario is not like on the very higher side of things in terms of sufficiency ambition, let's say, but still it features substantial efforts made by citizens and collectivities to put some sufficiency measures in place. So I'd say it's not a sort of very pushy sufficiency type of scenario. Sufficiency is just one of the features used in EnerGreen, along with efficiency, along with renewables, along with some CCS and hydrogen. But yeah, it's still substantial, right?
Yep. Thank you. So maybe I'll try to combine a lot of questions because unfortunately there's too many questions. Maybe we can try to address them separately at the end of the webinar instead of just extending the slot and write back with our thoughts about your questions, because I think they're quite interesting. So there's a lot of questions on, as I was saying, some, aspects that are maybe beyond the scope of what we're doing right now. One question that I find interesting is about, overall basically the how do you promote efficiency? How do you explain that it's not as prominent in the works? And this is a bit of a naive question because it goes, I think, to it's sort of contrary to the capitalistic society in which we live, because we're promoting reducing consumption as opposed to if you really oppose sufficiency on the one side as a model to continue to try to get as much as possible from the resources of our planet. But that's, as you were saying, these goes to a lot of uncertainty in terms of will we be able to extract these resources at what cost, and there's a bit of a leap of faith that is made in these scenarios. So how do you explain that sufficiency is not as popular, I guess, and not as talked about compared to other drivers in long-term energy scenarios?
I think one answering element for me is the fact that we are still very much focusing on only one indicator at the moment, which is the GDP indicator. So when we compare or when decisioners and policymakers can read and have a look at these different scenarios, it is already useful that they have different options on the tables and that they see that they can go on one scenario which focuses more on efficiency or more on lowering energy and more on sufficiency. So they do have the options, and it is essential that they have the option. But at the end of the day, in our existing system, which is very much focused on growth and on still increasing the GDP per capita and GDP, we are not making the decision to go for this sufficiency scenario, but it still exists and it is an option we have. Then it's a political question, I think.
Yeah, and if you allow me to complement, maybe in a strong sufficiency type of scenario, you will lose a few points, I mean, fraction of points of GDP growth, but it's not about degrowth, right? It's just about using, to some extent, this lever in addition to all of the other. It's not about doing only sufficiency, right? It's not about going back in our level of development or anything. It's about just reducing the waste, the waste of energy that is sometimes made today, transforming the way that we approach our consumption of energy and our representations actually of how we consume energy. Just to have this small effort made on the demand side of things, and it helps to lower the pressure on a lot of other technologies and materials that we will require to successfully make the transition. And basically, I'd say if sufficiency is not very popular, I mean, energy transition, I wouldn't say it's that popular today. If you ask people to do some efforts, they will tell you, okay, it's about the private sector making efforts, and the private sector will say it's about policymakers, and then the policymakers, they just see nobody wants to make efforts, so they align to that. So it's really about embracing the fact that we need to do the energy transition, and this is one lever that makes some sense to use, because it reduces the pressure on resources, on materials, and because it brings also co-benefits as we listed on, and that's how we should advocate for sufficiency. It's reducing uncertainties, adding co-benefits, and ensuring a higher chance of success for the transition, basically.
Yeah, thank you. And I think just to wrap up on this and to also take elements of the questions that have been asked, I guess there's really a work that needs to be done on trying to maybe value the impact of sufficiency from an economic perspective. But then again, we're talking about aspects that are difficult, that are not really super tangible, and to try to explore and break down what exactly are the constraints and the social inertia that we are dealing with. And I think, yeah, this is really an area that needs to be explored more. And I think there was a mention on this as well. This seems to be a very European concept as of today. The IEA, which is obviously the standard, talks about behavioral changes. But as we've seen, when we break down what we're talking about in terms of sufficiency, it's much more than just behavior. There's also a lot of social aspects and collective aspects related to that. So there's really, I think at this point, there's just really a lot of work that needs to be done just to specify what we're talking about and what are the benefits and co-benefits of applying sufficiency-related measures. I'm just reading, maybe because we're ending the end of the presentation, one point that I thought interesting about like potential rebound effect. Like if we reduce energy consumption, then we maintain energy prices lower, then you might have rebound effect, which I think is an interesting perspective as well. And you have specific examples that are given, like that data centers, for example, that could be exploding. And it's also an area where we don't have a lot of data currently, and it's hard to model. But yeah, overall, I think we will leave it at that for today. We will explore your questions and potentially do a wrap up and try to address as many of them as possible. But for now, I think we are going to allow you to go to lunch, I guess, for those of you for which it's time to go to lunch. For us, it is the case. And thank you very much for joining. We hope that you found this webinar interesting, and hopefully we'll see you in future events as well. Thank you.
Thank you very much for your attention and questions.
Thank you very much.